So this formulation is complex, so let us understand what is going on in this question. So there is a machine tool company conducts a job training program at a ratio of 1 for every 10 trainees. So that means if one person will train, then he will train 10 trainees. Keep that in mind. It will come in use in further. So from past experience, it has been found that out of 10 trainees hired, only 7 complete the program successfully. Okay. So 10 trainees are taught and only 7 pass. Rest 3 are released. See, it is given in question also, rest 3 are released. So now we are just trying to understand the question. We will formulate it further. Now here comes the main part of the question, the company's requirement. Okay, so for Jan it is 100 mechanists, for Feb it is 150, March it is 200, and in addition the company requires 250 trained mechanics by April. So for Jan, Feb, March and April, the requirement is given. It is 100, 150, 200 and 250. 100, 150, 200 and 250. Now this was the requirement. So now let us see what are the costs of this. So further, payroll cost per month. Okay, so each trainee 400 per month, each trained mechanist rupees 700, each trained mechanist who is idle, so it is 500. So now we get to know that there are three cases. One trainee will, like each trainee, here what we said that 10 trainees were here, so each trainee will be requiring 400 per month. Now when they get trained, in 10 trainees only 7 got trained, so what the 7 will be getting is that 700 per month. And if they are trained, and if they are brought to use for machining or teaching, they will be getting 700, and if they are left idle, they will only be getting 500 per month. So labor union forbids ousting trained mechanist. So like if there are mechanists who are sitting idle, still you cannot like fire them. That's what the question is saying. So now we have to formulate an LPP. So this was all about the question. So now let us think then how to start formulating. So here the objective function, as you can see, is not clearly visible. What is our objective? So this is a complex question. So now let us delve deep into this topic. In January, we can say there is 100 of people which are needed. Now 150, March 200, and April 250. So from here we will be starting a question. Now let us assume. Now we are starting to formulate. Let us assume that A, B, C, D, E, F. Since there are three cases, so we can assume that let A be people who are mechanists who are teaching, mechanists who are teaching. B are mechanists who are idle. Now this was the case in Jan. Now for Feb, let us C be the mechanists who are teaching and D who are idle. Okay. Similarly for March, E be the mechanist who are teaching and F be the idle mechanist. So these are the only 6 cases which are possible, and now accordingly we have to formulate our question. So keep this in mind that in January A are teaching, B are idle, in Feb C are teaching, D are idle, and in March E are teaching, F are idle. Now as I told you, if one person teaches, it will teach, he will teach 10 trainees. So for example, A is teaching, then how many people he will teach? It will be 10A. And how many of them they will pass? It will be only 7A, because in 10 trainees only 7 people pass. So keeping this in mind, let us start formulating. So now for January, 100 people are required, and for example in January, teaching are A people, as we assume A, and idle are B. So obviously this will be greater than equal to 130. Now let us see how. Because the already available people who are there are 130. So since the availability of the already trained employees were 150, see here it is also given. There are 130 trained mechanists. So that is why I am taking 100 plus A plus B greater than equal to 130, because 100 people are required, and after adding A and B, that is training mechanists who are teaching and mechanists who are idle, they will be greater than equal to 130, because 130 we are already having. So this is our first constraint. Similarly, you can do for Feb and Jan. So what you will do, in February requirement is 150, and we will add C and D, as I've already explained in February, C and D. So what they are, you already know. So C plus D. Now what that will be greater than equal to? It will be greater than equal to 130 plus. Now see, here is the part that since A has already was teaching. So as I told you, when A teaches, there are 10 A employees who are getting trained, and in that 7 A get passed. So we also have to add the passed people who have already passed the training. So here it will come 7A. Now for this was for Feb. Now for March. For March, it is given that there are 200 which are needed. So 200 plus E plus F. Now think that what it will be greater than equal to. So it will be greater than equal to 130 plus 7. Now plus. Since C people were teaching, so they will teach 10 C people and only 7 C of them will pass. So we have to add them also. So see, 7 C people we have added. Now for April, it is given that we need 250. So 250, sorry for the handwriting. So you just need to know what is going on in the problem. After that you can do by yourself also. So it is 250 here in April. So it was the requirement of 250. So what will 250 be? 130 plus 7A plus 7C, and now E people are training in March. So now I am reiterating myself that if E people teach, they teach 10 E people, and from 10 E only 7 E will pass. So I have to add that also. So one second, let me erase this. So 250, let us. So now 130 plus 7A plus 7C plus 7E. Okay. Now they all will be less than equal to 250. Oh, sorry, I mean greater than. Okay, greater than equal to 250. Now why? Because the requirement is of 250. So obviously, if the requirements of 250, the people cannot be less than 250, because this will not create a constraint for us. So we have taken this as greater than equal to 250. Now these are the initial constraints of this problem. Now still there are so many things which are left in this question, and that is why I called it a complex question of formulation of LPP. So let me erase and this part, because you have already understood this, and I'm going further with my explanation. So these constraints I'm assuming that you have understood. Till April we are done with the constraints. Now the objective function. What will be our objective? Let us think. So we have to minimize the cost, because let see here, 400 per month of each training, 700 per month for trainee who is passed and is machining or teaching, and after that each machinist who is idle. So these are the cost involved with the machinist. So we have to minimize these costs. So how will we minimize these costs? Let us go to that part. See, 400 for training. So how many trainees we had? If you remember, A, B, C, D, E, F. How many trainee we have? A taught, okay. After that B was idle. Now C taught. After that D was idle and E taught. So if A taught, it will be 10A, because as you must be remembering that 1 people teaches 10 people. After that C taught, so it will be 10C. After that E taught, so it will be 10E. So this is the cost of trainees only. Now these many people are trained. Let's go after that 700. Now this is the cost for people who are machining or teaching. So see, A was teaching, so A, C was teaching, and E was teaching. After that, 500 is the cost of people who were idle. So as we assumed in this question, B was idle, D was idle, and F was idle. So B plus D plus F. These were the people who were idle is equal to Z, and this we have to minimize. So this was a very good question of formulation of LPP. So that is why I took it in this section. After that, in the next coming videos, I will be solving LPP. So thank you everyone.